Hi everyone, I'm going to discuss measure of central tendency. Measure of central tendency provides a very convenient way of describing a set of scores with a single number that describes the performance of the group. So for example, if like we have a set of students who have taken the entrance exam in a university, then of course, for us to come up with a meaningful summary on the results of the scores, we can describe the scores by assigning a single number that describes the performance of the entire group. Like we can work on the different measures of central tendency, which I will introduce a little later. And it is also defined as a single value that is used to describe the center of the data. So there are three commonly used measures of central tendency class, and these are mean, median, and the mode. So you are somehow familiar with each of these terms. You were able to even come up with calculating each of these measures of central tendency. So our discussion will focus on how we calculate and interpret the mean, median, and the mode. And for this discussion, we will be dealing with ungrouped data. So when we say ungrouped data, this is something to do with individual representation of each value or score. If, for example, we're going to consider your grades in your previous grades in the last school year, then let's say you have 13 subjects and you want to calculate the mean of your main grade for the last school year. So what you're going to do is to work on calculating for the mean and you come up with one single value. Now, you you come up with calculating the ungrouped mean if you're going to calculate for the mean, meaning you represent each observation individually. When we say group data class, group data, this is representing an observation by a class interval. So here we will be dealing with calculating for the mean of ungrouped data. So let's go with the mean. Mean is the commonly used measure of the center data. This is also called as the arithmetic average or simply average. And the mean is calculated by working on this formula. And we denote in our discussion the mean by this notation, x bar. So this is equal to summation of all observations, where x sub I here is each item or element in the total n observations. So if we're going to consider, for instance, again, your 13 grades in the different subjects last school year. So there would be a total of 13 observations, and that would represent or that would stand for n. And each grade there is your x sub I. We can assign, for instance, your x sub 1 for your grade in English, x sub 2 for your grade in math, x sub 3 for your grade in social studies, and so on. So this sigma notation would mean summation. So this is summation of all the elements divided by the number of elements. So basically, if you know how to calculate the average, that is exactly what we're going to do. So if you want to describe your grades last school year using the arithmetic mean or the arithmetic average, what you will just do is add all your grades. So add the 13 grades from the 13 different subjects, and then you will divide that by the number of total subjects, which is 13. Now, later, I'm going to give you example on how to calculate for the mean. So we will be working on ungrouped data set. So take note, class, that the mean is affected by the outliers. So when we say outliers, these are extreme values. So a very high or a very low values. Let's go back with the example that I have mentioned as regards to the 13 grades last school year. Now, for instance, you have generally from all the subjects you've got line of 9, and there is this one subject, let's say math, that you got a grade of 77. Now, if you will notice, if you get the average of the 13 subjects, somehow or really it will affect your grade, because your grade or your score is affected by this outlier, in the example by this very low grade, let's say in mathematics. On the other hand, if your grade is like line of 7, and then you have this one grade which is line of 9, your average will be pulled up a little by this very high grade. So that is how what we meant by the mean is affected by the outliers. So let's work on this example. Score of students in Math 8 quiz consists of 30 items are. So if we're going to count the number of students who took the quiz, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there were 15 students who took Math 8 quiz, which is a 30-item test. So here we are asked to calculate for the mean score of the quiz. So working on the formula, so this is sum of all the values all over the total observations. So we will be adding the 15 scores. How many 27? 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7 plus 29. And then the sum will be divided by 15. Now, if the answer is non-terminating, we will round off the value to two decimal places. So after calculating the sum is equal to 372. Again, divided by 15. So this gives us 24.8. Okay? Now, how do we interpret the result? Like, students who got below the average score did not perform well, while students who got a score higher than the mean score perform in comparison to the entire students who took the quiz. So the following are the ages of the 10 respondents in the survey. Calculate the mean age. So we have 10 respondents here. So this is equal to the sum of the 10 of the ages of the 10 respondents. 1, 2, 3, 4, 5. So we have 530s. Two more. All over 10. So the sum of the numerator equals 299, and we will divide that by 10. So the mean age of the 10 respondent is 29.9. So that's how we calculate the mean. Now, in the event that in a set of data we have a lot of outliers, so it is suggested that we calculate the median instead of working on the mean. So when we say median class, median is what divides the score into two equal parts. So 50% lies before the median value and 50% lies after the median value. So it is known as the middle score or the 50th percentile. So this is the middle value. Now, that's why this is called also as the measure of position, because we're going to arrange the data in ascending order, and by inspection we will identify what is the middle value. That's why the median class is not affected by these outliers or extreme values. So if we have a lot of outliers, so we can calculate for the median instead of the mean. Now, this is how we calculate for the median, and we denote the median by this symbol in our discussion. Now, we have two ways of working on the value of the ungrouped median. One is once you have arranged the scores or the values in ascending order, take note that you have to arrange them in ascending order. So, the middle value would automatically be the median if n is odd class. So when we say if n is odd, if the number of observations or total observations is odd. For example, you have 15 respondents. So you arrange the value from the 15 respondents, and then you get the middle value that would be the mean. On the other hand, if n is odd, of course, you still have to arrange the scores in ascending order, and then you get the average of the middle values. And we will do that in this example. Okay. Now, in the first example or example 3 in our discussion, find the median electricity consumption of 9 households. So, take note class that n is 9 and this is odd. So, I intentionally arrange the values in ascending order. So, we will just get the middle value, and that would automatically be the median. So, since this is 9, the fifth value would be the middle value. So, 1, 2, 3, 4. So, this is the middle value, and this is the median. Now, 50% of the respondents consume more than 2,500, and the other 50% of the respondents consume less than. Okay. Now, here, find the median number of customer complaints in the last days. So, this should be in the last 10 days of a call center company. So, here, N is 10. So, this is an even value. So again, the values here are arranged in ascending order. So there are two middle values for n equals even, particularly n equals 10. So the fifth and the sixth would be the middle values. So these are the middle values. So the median is equal to the average of the two middle values. And this is equal to 11.5. So that is the median values for the value for this example. Now we go with another measure of central tendency, which is we call as the mode. The mode class is the score or scores that occurred most in the distribution, meaning the mode is a value which has the highest frequency. So it is classified as unimodal, bimodal, trimodal, or we call this multimodal. So unimodal, if from the set of data, we only have one value which has the highest. frequency. When we say bimodal, there are two values which obtain the highest number of frequency. While trimodal, we have three values which obtain the highest number of frequency. Meaning there are three values who've got the same number of frequency, which is the high. There are three highest frequency. Okay. So example for the following are the scores of the 10 students of section A, B, and C. Okay. So we have 10 respondents from each section. So we're going to now class in the event that the score or the value is unique. So there is no common value among the observations. Then we represent the value of the mode equal to 0 because there is no highest frequency since the frequency will always equal b to 1 since everything is unique. Okay, take note of that. Now, from the score in section A, we have 24, 24, but there is this 20, which is the score of the three students. So it has the higher frequency. So there were three respondents from section A who garnered a score of 20. Okay? Here. So meaning the mode which is denoted by x sub 0 is equal to 20 from section A, and this is unimodal because we only have one highest frequency, and that is 20. Now, the mode on the other hand for section B, if you're going to look at the value, there were two students who scored 24 and there were also two students who scored 18. So the two has the highest frequency. So we'll come up with two modes here, 24 and 18 from section B. And this is bimodal. Now, the mode for section C, so we have like 25, 25, 25, 21, 21, 21, 18, 18, 18. Now, there were three students who scored 25, another three students who scored 21, and another three students who scored 18. So, three is the highest frequency. And we have three modes for section C, and the modes are 25, 21, and 18. And this is from section C. And this is called as trimodal or multimodal. So this is from section C. So again, when we say mode, this is the score or the scores that occurred most in the distribution. So this is a score with the highest frequency. Now, again, in some situations, we come up with two highest frequency and we call that as bimodal. In some situations also, we come up with three highest frequencies or more. So we call that trimodal. We also have one highest frequency and we call that as unimodal. Again, in the event that the observation is unique from each other, then there is no highest frequency. So we consider the mode equal to 0. Okay, so I hope you were able to understand the idea of the measures of central tendency for ungrouped data.